lights, there's so many of them, and they're so inefficient that it might actually be adding a little extra heat to the room. So, is that still enough light for you to see?
Yeah.
Or should I like do
No,
that?
just leave them all off.
All off? Okay. I'll throw things at you every once in a while, okay?
Oh, I'm good.
You're good? Okay. I can throw things at you if you need me to keep you away.
No, I was just kidding. I can get you like one of those squishy like apple things, and you can throw them at CP students.
Oh, even that last 30 seconds was on the video. Yay.
Oh.
Now there's a record of me throwing things at students. Okay, so last kind of preamble before I start. So 3 main things you need to know. Can you factor and cancel stuff? Do you have that skill? 2, do you know how to factor so that you can add, subtract, multiply, divide? Do you possess that skill? And then now we're kind of bringing this all full circle. Remember how I would make you guys do the quadratic formula and factor and solve? We're going to need to bring that in again because we're doing equal stuff. So, honestly, most of my notes are really just, I'm going to do a lot of examples. So, why don't we do an example? Okay, so we've actually done a little bit of this, I think, so far as a group. The idea of how do you deal with fractions? And maybe you've heard this phrase before, cross-multiplying.
Yeah.
You've heard that before? Yeah. You can cross-multiply, but you have to make sure you do it in the right scenario. The right scenario, the only scenario, by the way, for a cross-multiply is fraction equals fraction. That's it. If you have fraction equals fraction plus some other crap, don't cross-multiply. It has to literally be a fraction, then an equal sign, then it's another fraction. And that's the only time it's valid. And if I haven't shown you why that cross-multiply works, the rationale here is what you're doing is you're timesing this side here by x plus 2, and you're timesing this side here by x plus 2. And that's valid because you're doing it to both sides of an equation. And what that does is it causes this x plus 2 and that one there to cancel. And you're also going to times both sides of the equation by this x down here. You put an x there and you put an x here, which then causes this x and that one to cancel. Whenever a teacher tells you to cross multiply, that's what you're actually doing. But it's sometimes just faster than to put some arrows and say, just bring this one up to there and bring that one up to there. So does it make sense for me just to hop now to, you have to do an x plus 2 times by the 5, and you have to do a 4 times by an x. Do you guys see that? So like just this guy comes up here, that guy comes up there. You don't need all the extra stuff, but technically that's what's happening.
So the bottoms cancel.
And the bottoms are now gone, yeah, because this bottom right here has been moved up there, and this bottom has been moved up there. At this point, we just need to do some of our algebra skills. So this guy right here, maybe, can I take the 5 and put it in the front instead, just so it makes more sense? Like, putting it as the last number is fine, but... So now we need to expand, hence the whole why we practice that so much. So 5x plus 10, that's just 4x. There's no point in having a times between them. How do you solve?
You subtract 4x to the percent.
Sure. Maybe you've heard the phrase combine like terms. So I like to make that silly little joke about, get all of your x's as far away from you as possible kind of thing. With x's being the double entendre of your x's. So collect your x's, get them far away from every other number. So that means this 10 has to go way over here. There, x is negative. Does that make sense?
Okay, hold up. I did it.
Too fast there, or did you follow? Collect your x's, get rid of them. You good?
Yeah.
You just had a, you're good? Okay. Okay, let's try the next one here. In this scenario here, I made this one on purpose. Do you have fraction equals fraction? Yeah, you kind of do. Why?
Because it's over 1.
Sure, exactly. Says it with such a... like my 3-year-old says it that way, but yeah. Yeah, if you don't have a fraction, you could make it a fraction if you make it over top of 1 sometimes. So now we can cross multiply. So I'll just draw some arrows here. You'll do 10x times by 1. I won't even write that. And you'll do 3.75 times by 25 plus x. So Just bring that guy up there, that guy up there. All right, I need some calculator help here. Anybody got a calculator nearby? What is the whole thing up, but you still have to FOIL it though. So that's my next question. Does anyone have the ability to tell me what 375 and 25 is?
93.75.
Thank you. 93.75, and then I guess we'll have 375x. All right, we're at the same point again. Since it's like a linear equation with no squareds, collect your x's, get them far away from your other numbers, and divide. So exactly. So group your x's together. That's going to be 6 1/4, I think. And I'll need someone else's help with the calculator again to do dividing numbers. All right on the dot?
Yep.
Anybody else get 15? Anybody else try it? Not that right.
I
Okay.
feel like I'm wrong when everybody's signing.
No, Latoya's got 15.
You're not wrong.
You got 15 too? Okay, cool. Does this make sense? Is this familiar-ish? Like you've done something like this before in your past math lives?
Well, I got 14.84.
I got 15.
Why did I get 14.84?
So you did
Oh, I
93.75.
did 92.75.
Okay. Okay, so we're cool on 15 then? Okay, if I can give one piece of advice, when it comes to like test questions, if it's a written test question, I guess you can't really do anything different. And if it's numeric response, the same thing. But if it's multiple choice, sometimes a faster way of solving multiple choice is just to take the 4 different answers they might give you, like A is 15, B is 16, C is 12, whatever the answers are, right? And just take those answers and plug them back into the original equation. Have I ever talked to you guys about just the idea of guessing and checking? Well, you totally could do that if it's multiple choice, just to try to check your work. So 15 times 10 over 25 plus 15. See what that actually does equal 375? No. If you have time, you could check. Still good? Okay, those are supposed to be like the warm-up ones. So now for like the...
I was like, oh yeah, it's so easy.
Sorry. Those are the warm-up ones. Here's kind of the typical question I need you to be able to do. Okay. We have an equal sign, but in addition to that equal sign, we have a subtraction sign. Addition, subtraction, never mind. All right, can I cross multiply?
No.
Not
Yet.
yet. Good, that's the right word. Yeah, we will, but that subtract sign right here is kind of a pain in our butt. So we have to try to find a way to fix that. So my advice is I'm just going to put a line next to this stuff over here, and we're just going to ignore this guy for a while. That whole 18 over x squared minus 3x, it's gonna, we'll come back to it. This side over here, we have to give common denominators to. So when I talked about adding and subtracting, I pointed out how it was like cross multiplying. We're going to take this x minus 3 and put it here and here. And we're going to take this x and put it here and here. So what you'll have then is 6x and 5 with a bracket x minus 3. And now we still have the denominator, by the way. You know how cross multiplying gets rid of fractions? That's not what we're doing yet. So we still have to have the bottom of these fractions. We haven't gotten rid of them yet. So I might write this next step then as we've got 6x minus 5 bracket x minus 3. And the bottom of the fraction still exists. It's x bracket x minus 3. You might be a step ahead of me here. We can do some FOILing. Well, expanding, I guess is the word. Where you can, like, those guys.
5x minus 15.
You should have a plus 15.
Or, yeah, plus
Okay.
15.
Yeah, because what you'll get is a 6x, you'll get a minus 5x, and then the minus 5 and the minus 3. Oh, so careful with those minuses, like make it a plus 15. By the way, I usually recommend, I don't have like a golden rule as to why, but I myself, when I solve a question, I rarely FOIL at the bottom of things. The reason why, if I have a great reason, is that I rarely find it useful. I can always FOIL later if I need to, but I rarely find it that it's helpful to. But the top, it was helpful, because you guys see how these two terms, they can go together. So that's why I would FOIL the top, but the bottom, I don't actually see any point to it. So 6x minus 5x gives you x plus 15, and I still have the x bracket x minus 3. Okay, there's the next step, though, is that this is where it's similar to what we did before, but there's actually stuff it's equal to now. So what was it? It was 18 x squared minus 3x. Before I go any further than this, because we're sadly only halfway done, is everybody okay with that first little bit?
Yeah.
We'll follow that? Okay. There is one more thing we can factor. And it's actually this guy over here on the bottom left-hand corner. And it probably wouldn't hurt to factor it because there's actually something nifty that I made on this question on purpose to show.
It's both the same.
Yeah, good. You're already ahead of me on that. It becomes x minus 3. And that becomes 15 and x minus 3. On this particular example, if you see this denominator is the same as that denominator. We don't need to cross multiply. We could, but we may as well just cancel. Because you have something on both sides. And if you ever have something on both sides, you can cancel that.
That's cool.
Yeah. Now, let's say that didn't make sense, though. I can show you another reason how this might work. You know that whole cross-multiply concept? Maybe what you might want to do instead is just half cross-multiply. So maybe you take this guy right here and bring it up to the top over here. So you have like x and x minus 3. But like say don't bring this guy to the top. Just bring one of them there. If you bring this guy up here, now can you see that you have them on top of each other and they cancel? So like regardless of how you look at it, if you ever have fraction equals fraction and the denominators are the same, you can just kind of get rid of them. And now we're left with 18 equals x plus 15. How do you solve?
Bring the 15 to the other side.
Got it.
I'm so smart.
Combine like terms.
So I got 3. Anybody else able to?
What I
Get
was
to that?
wondering, like, is it okay for like, is what I did because I went ahead, is I FOILed or like expanded on that one side so that they were the same.
And did all of the x squareds cancel when you're done?
Well, yeah, I just kind of did what you did. I just like canceled out the bottoms because they were the same.
Yeah, well, that's fine. I mean, you got to the same place then, it looks like. So. Okay. We're actually not done this question.
What?
Yeah, I chose this one purposefully just to point out a couple of odd circumstances that can occur in math. Okay.
More than one, isn't there?
Side note here. I need to do a bit of an aside. Maybe don't write this down here. But there is the possibility sometimes that there is no answer. We've talked about this before. The idea of, say you have a quadratic that looks like this, and I ask you where it's going to cross, and then you tell me it doesn't. You guys are aware of that possibility that sometimes there is no answer to a solution. Okay. There is also a possibility called an extraneous solution. And maybe you've heard that word before if you're in my 20-1 class. I don't expect this on the 30-2 diploma, but I feel like I should prepare you just in case. Okay. So the word is called extraneous, and it's different than this though, okay? Having no answer is different than an extraneous answer. Yes, an extraneous answer, that's how you spell the word, by the way, is when you get an answer and like you didn't make a mistake, like you did all your work properly, but when you go back and check your work, for some reason when you look at it, it's an impossible answer. And I want to show you how that applies to ours. We just got the answer x equals 3. But go back up and look at the very top here. Right here, could you plug 3 in?
It would be 0, so it can't work.
That doesn't work though. Does that make sense? And so what we've created now, or discovered at least, is a contradiction where x cannot be 3, and yet somehow we got the answer where x is 3. And so this would be referred to as an extraneous answer. There actually is no answer to this particular question because the only answer we got, which was 3, is apparently impossible. Okay. I was talking with Dakota earlier because she had to go, so she couldn't be here for this class. And this made sense to her, so I'll try it with you. You guys ever heard of those scenarios where, like, a war veteran, maybe they lose their arm, And but they still, in their mind, they still feel like their arm or their hand is there. You ever heard of that before?
Yeah.
I feel like that might be similar to an extraneous solution, where if I were to approach it from a graph point of view, I'm just going to find some more places to work here. Here's a graph where hopefully clearly these graphs don't cross. Hopefully you agree that they don't cross, therefore there's no answer. An extraneous one might be more where like these graphs do cross, but for whatever reason, this part of the graph up here is not allowed to count anymore. I don't know for what reason, but and so maybe you're only allowed to count the part of the graph that exists right here. Okay, I really drew that very poorly. Right here. Boy, that was still close though, wasn't it? In that box that I drew, do they cross? And then hopefully you'd say, well, no, in that box that I drew right there, they don't cross. Maybe that's similar to like the guy who loses the hand, where yes, the graph does cross, but it crosses outside the parameters of what's allowed. Does that make sense? Maybe as like your mind still thinks your arm is there, but actually it's not allowed to be there anymore because it got cut off or whatever, right?
It's like astronauts when they're trying to get used to gravity.
Oh, that's a clever idea.
Gravity again, it's hilarious.
Hmm.
They just drop stuff.
Like a drunk person. Anyways, does that make sense? Have you guys heard that word before? So to answer this question here, I threw this one in very much on purpose. There is no answer because as we check our work, it doesn't work. Okay. I'm not expecting this, but I want to point it out in case it comes up.
So just so we know I'm looking for it.
Exactly. Just make sure you're aware, but I'm not counting on this being a regular occurrence. Okay, does that work? Let's try another example now that I've thrown a really weird twist at you there. So this example here, do I have the ability to cross multiply yet? Say no, because of this stupid minus sign sitting here. So I have to try to find a way to deal with the left-hand side. So I'm just going to like, I don't know, that. Over here, I'm going to leave the a and the 2 minus a, and I'll deal with that stuff later. I need some room now to put these two fractions together. Any thoughts as to where to start?
There's a difference in squares.
You can just cancel those two and ones, can't you?
Not quite though, because they're binomials and they are different, right? Like you can't just go or something like that.
When you do the difference of squares, they're going to cancel anyway.
Well, this one will be. Let's actually go through the process then. You'll have a 2 over an a plus 2. Now the top of this thing is not a difference of squares because it's not a minus sign. So you actually can't do anything with the a squared plus 4. It has to be a minus sign. However, the bottom, we can. The bottom can then become a plus 2 and a minus 2. So, showed it's a noble thought, but unfortunately, actually, nothing actually can be canceled yet. So, it's a good try.
Even if you put a negative in front of the...
If you try that little negative trick, what would happen is it would make the a negative and the 4 negative, and then they'd both be negative. And you need to have one of them to start positive, and then the second one to be negative. So, yeah, we're out of luck. It's actually not that bad, though. Do we have partially common denominators?
Yes.
Like, can you guys all see how there's at least an x plus 2 already in common?
So you can cross multiply.
Wrong word, but right concept. We're not actually going to cross multiply, because cross multiply is on the other side of an equal sign. Yeah, I think, like, I get what you're saying here, Latoya. You take that a minus 2 and you put it here, and I'm really running out of room, but you put it there as well.
Yep.
That's what you were going for?
Yep.
Okay. So I'm gonna,
But then can those two cross out then?
well, we don't want to cross these ones out because we just put them there.
Yeah.
Does that make sense? It's such a common thought. Like, please don't feel embarrassed if you think that ever. Because so much of the time I'm trying to teach you, hey, cancel. And you might look at this and say, hey, look, I can cancel.
I know, and we just put that there.
Yeah. So what we can do is make one big fraction where you have an a plus 2 and an a minus 2. And then on the top, I'm going to do some foiling if you guys are okay with this. I'm going to foil the 2 into the a to give me a 2a. And I'm going to foil the 2 into the minus 2 to give me a minus 4.
Minus a squared.
And we're going to minus a squared.
Is it a minus 4?
It is. That was my next talking point here.
I put plus 4.
Anyone want to take a stab at explaining why it has to be a minus 4 not a plus 4?
Because that minus and a plus sign turns into an a.
Yeah, make sure you're super careful on subtracts. The negative a squared is just like negative x squared. But this negative has to apply to the 4. So we have to subtract 4. Lost you there?
Yeah.
Okay, so this negative sign right here applies to the a squared, so that's why right here it's negative a squared. But this negative sign also has to apply to that 4 right there. So rather than it being plus 4, this negative actually makes it into a negative 4. It's almost like this negative sign has to like also distribute across both terms as well. So you got to take the 2 and times it by both terms. But for the second half here, you got to take a negative and times by both terms. What can you combine? I guess, yeah. It's kind of ugly because you have a negative a squared, you have a plus 2a, and you have negative 8. Still good? Do I now have fraction equals...
Fraction is a over 2n is 8.
Very good. Do I have this scenario? Yes, I do. Finally, it's time to do some cross multiplying. Actually, I chose this one again on purpose to try to illustrate a point. We can cross multiply, but there's actually something kind of almost able to cancel. We have the same thing almost on both sides of the bottom. Yeah, do you guys see how there's an a minus 2 right here and a 2 minus a right here? If I play my little negative sign trick, where I go like a negative sign perhaps here, and a negative sign here, then it actually flips these guys around so those ones can cancel.
Boom.
Boom.
They can cancel even though they're both on the bottom.
So then
Well, because they're on both sides of on opposite sides of the equal sign. Does that make sense? You have the same thing on both sides of an equation. So if you ever have the same thing on both sides, they cancel. It would be like if I told you that you had 3x equals 3. You have a 3 on both sides, right? So you can cancel the 3's. It does leave a 1. Does that make sense? Okay, so what we're left with now is a negative a squared plus 2a minus 8 equals a negative a. This guy down here on the bottom, I can cross multiply him up over here. There's actually nothing left to cross multiply the other way, so I'll just put the a plus 2 next to this guy. That makes sense? I took this guy over here.
I'm ahead.
Oh, and then just like a 1.
Yeah, like there's technically like a 1 on the bottom here. I didn't even bother with that 1. Skip that one. Okay, at this point we have quadratics, which is why I spent a lot of the beginning of our unit kind of reminding you about how to solve quadratic things. So we do need to FOIL out this little bit here real quick. So that'll give you a negative a squared and a minus 2a. Whenever you have squared stuff, you could end up using the quadratic formula, but this one's actually kind of fortunate because, again, we actually have the same thing on both sides. What's on both sides again?
Negative squared.
Yeah. You see how there's a negative a squared on this side and a negative a squared on this side?
But this isn't.
So actually, it isn't actually quadratic anymore, though.
Oh.
So it could be, though. I just want to point out when we do it the next question, I think it is quadratic. At this point here, we've been here before. Add your like terms together. So I'm going to add 2a to this side, which means I get 4a. I'm going to bring the 8 the other way, make it 8, and then do a little divide by thing, and I get 2.
But it's extraneous.
Yeah.
That makes me literally just. Come on.
So yeah, do you guys see why Lisa's a little ahead here? But why it's extraneous is that, like, say back about, I don't know, maybe here's a good step. Can you plug 2 into a 2 minus 2 thing? No. So, like I said, it could come up. I'm not planning on making this like a major thing that we do all the time, but it could. So, yeah, it's extraneous again.
But it's going to be on our quiz.
I might throw 1 on there.
Yeah, you're definitely doing one.
So this is a secret. Well, no, I don't know. I actually haven't made your quiz yet. Are we good so far on how to solve that? Okay, let's try one where it's not extraneous. I'm pretty sure this one's good. Do you guys want to try this one by yourselves, or should we do another one as a group still?
You can do it by yourself.
By yourself?
Yeah.
How about this? Take 2 minutes to get a head start, and then I'll start. I won't say anything, but I'll start writing on the board behind you. And then if you are stumped, then you can look at what I do. So. I think after this, by the way, we'll take a break. I know I still have more left, but I think now's a good break time after this one. Sit for a while. I feel like it's not as hot as the lights out.
Yeah, I could.
Doesn't it seem like that's true?
Yeah. Is it? It is. Oh wait, no, jumps. This is what it is so far. I just told it, I thought I was done.
So then you gotta make that over the 42. And then cross multiply, you'll get a quadratic. You actually have to use the quadratic equation to try to solve.
Whoa, that's a big number.
Yeah, I know, right?
Dang.
Alright. If you're stumped and you want to have a hint, just look at the board. I won't talk. I don't want to distract you guys too much. Here's how you could solve it. Here's about the halfway point. Well, maybe. Let's see whether you get to this. I put the left-hand side together, and I get negative 13 on the top, because A's actually cancel, and an A with an A minus 13 on the bottom, and I still have the 1 over 42. So if you can get to this point here, now you're at the cross multiply step. Does that make sense? Okay, I'll just keep going here then.
There's no answer. Or am I doing it wrong?
Did you get a negative under the square root sign?
Yeah.
Yeah. Now that's a different reason for no answer. I know. I'm so mean today in this class because none of these questions actually have answers. I'm trying to illustrate a point, though. Hopefully you get that because I want to show you some of these odd scenarios. So, but let me get there with everybody else first. 13 times 42 will equal a squared minus 13a.
Alright.
What is 13 times 42?
It is 546.
Thank you.
And 13 plus or minus
546.
-2000.
So in purple, I kind of did a little bit less work, but you got to cross multiply. You get a quadratic, and the quadratic gives you an a squared, a minus 13a, and you should get apparently 546, as it says.
Come on. Why did I take my break?
You feel like you got this?
Yeah,
Yeah.
I like this stuff.
All right. I don't want to go too fast though. Sometimes I do that too much.
I'll figure that right.
Do you guys get what I did there, or did I need to explain that? I should explain it. So I took the 42 times by 13, which apparently is minus 546. And I took the a and the a minus 13 times it up here by 1. But I just did the a times a to give a squared, and a times minus 13 to get minus 13. And there used to be a minus 546 on one side, so I brought it to this side, made it a plus 546. The last step now would be to use the quadratic formula. The only crappy thing is that you actually get a negative square root thing, so it would be like negative 13 plus or minus the square root of negative 13 squared minus 4, 1, 546. over 2 times 1.
I ends up being like negative 2015.
I'll just say like a negative. So then there's no answer. I'm sorry, I'm kind of a jerk today.
Come on, show.
Just won't let anybody have an
What
answer
is solve
today.
my problem? Show me another answer something.
What's that?
That's Friday.
Yeah, so I guess here, let's talk about that and we'll take a quick break here. So tomorrow's gonna be a work day. We're gonna do a quiz on Friday. Monday we're gonna have another work day and we'll do a unit test on Wednesday. In terms of your assignment, I'll make your assignment due next week Tuesday with the unit test though, okay? Like I don't think it's fair to expect the assignment by Friday. But can I still take your journals though every Friday still? Oh, and hopefully by then we'll have at least 10 questions built up at some point. So, because we'll do a couple more tomorrow as well. Does that make sense?
Yeah.
So, okay, go take a break. No, that wouldn't be fair to me. No, that's not fair. So, go take a break. When you guys come back, I do have a few more questions I want to do, and I hope that maybe 1 or 2 of them actually do have answers, as opposed to all these ones I've been giving you where there are no answers. But, do you guys get why I'm doing this? I'm trying to show you the weird cases, just so that if they come up, you've seen them before. Go take a break.
Hold on.
Take a break.
I'm leaving.
All right, come back at some point. Okay, why don't we just do, let's skip the next one. Let's just do 2 more examples, and then I think we get a sense here. Do you guys feel okay with this?
I feel good. The extraneous make me mad, but other than that,
Okay.
Thank you.
I feel like it may just be one of those things where you just need some practice now, where you're doing it by yourselves. So.
Yeah, I just
Can we just do one more here together as a group? And then I do want to do a word problem one. And then I'll let you guys, if you want to take off, you can even do that if you. So, okay, let's try this one here. Before we even start, you should always consider factoring, because factoring does make your life easier. You can make this be an x plus 2 with an x minus 2. And this middle term here, you can take a 6 out, right? So what does that leave you with?
wait, I'm just running it down because I didn't
Oh, sorry, you guys aren't that. I'm too far ahead.
So, oh my god, this is the bottom question.
I'm just gonna watch it.
Did I go too fast?
No,
I'm just
Remember
catching
doing
up
this
to
one?
the 6.
Oh, I was just going down to the bottom one. I was going to skip one to save time here.
I just didn't know.
Okay, sorry. So I'm factoring the bottom basically wherever I can.
can the X minus 2 cancel out?
Okay, that's a great talking point on this one here, because I've been doing that for the last little while, where if there's been an x minus 2 on this side and an x minus 2 on this side, I've been canceling them. But I haven't actually put these together yet. So that is probably going to happen, but just not yet. That's all. So good thought, though. We're not at that point yet. So do we have partially common denominators? Sure, there's an x plus 2 in both of these guys. Let me just change colors here. So we need to put an x minus 2 here and here. And we have to put a 6 up top here and maybe there. Alright, one big fraction then gives you a 6, an x plus 2, and an x minus 2. And I'm going to try to do a couple of steps together on the top, just to save space. So let me know if I lose you here, okay? 6 times 2 is going to give me 12. I'm just going to keep that in my head, though. So the 6 times 2 is now 12. And up here, if I FOIL this, it'll give me a 10x and a minus 20. That means you're going to have 10x, because that's the only x term left up there. And there's a 12 and a minus 20. So 12 minus 20 would give me minus 8. I'm just kind of saving space here.
Oh, you just like.
No.
Okay, I'm good.
You cool?
Yeah.
Okay, now for Latoya's idea. So now we have the spot. Yep. Credit here. So now we have a time where there is a fraction equals a fraction, Cross multiplying is valid. And so I can cancel those x minus 2s. Okay. And I may as well take this remaining stuff and times it up top that way. So you'll have a 10x minus 8 over on this side. And all that's left over here is a 1. So can I refoil this back out again in one step and go like 6 times x is 6x? And 6 times 2 is 12, and just take it to that point. And last step here, then just combine like term stuff again. So bring the 6x back the other way by minusing it. You get 4x. Add 8 the other way, gives you 20.
This one actually worked.
Yeah, I finally gave you one that works.
Yay!
Yeah.
You can tell your parents, we did 5 questions in class and we only got one of them had an answer.
Like, what kind of teacher do you have?
Yeah. Okay, does that make sense?
Yeah.
Okay. When I started class today, I showed you guys those 3 outcomes I'm supposed to teach you. And one of them I find frustrating. It says, solve problems. And it's very vague. You're probably going to get a word problem, which not many people like. I actually talked about this a bit yesterday, where there was that question about, on the assignment I'm going to give you, about a guy who, if he bikes faster, it takes less time, that revolutionary concept. I've seen them give the actual equation before. If they give the equation, it's usually not too bad. It's kind of a jerk move not to give you the equation. So I'm going to give you the equations, obviously, because I think it's really challenging otherwise. But when it comes right before the diploma, I think I'm just going to hold off on that until right beforehand, if you guys don't mind. Then I'll talk about how to make an equation on that off chance that they don't actually give you an equation. I felt like I said the word equation 7 times there. Does that make sense?
I think you actually said 8.
Okay, so anyways, here's a scenario. Someone buys some t-shirts for $4.50. She keeps 2 shirts for herself, sells the rest for $5.60, makes a profit of $10. How many shirts were there? I'm going to give you the equation, and if you can probably see where some of the numbers came from here. She bought them for $4.50, and when she bought them, there were a certain number in the case. Later, she sells them for $5.60, but she didn't sell all of them. She sold all of them minus the 2 that she kept, and by the time she was done, she was making $10 a shirt. So that's kind of where the equation comes from. So at least for right now, is it cool if I give you the equations that you need for this and you use them, and then later we'll talk about how to make one if you had to. So at this point here, let's solve. So do we have common denominators? No, we do not. Put an x here and here, and an x minus 2 here and here.
And then cancel them.
Thanks, Shelley. Don't cancel them, because that just defeats the purpose. So you'll have 560x. Okay, I'm going to do a couple steps together. Make sure there's a minus sign there. Be super careful with the double negatives, okay? You'll have a minus 540x, and you'll have a positive 900.
You mean 450?
Sorry, whatever I said. Listen to my screen, not my mouth.
Okay.
Yeah, listen to the screen, okay? 450. And on the bottom, you'll have x and an x minus 2. So 560 minus 450, 110?
Yeah.
Okay, so at the point where we're finally able to do some cross multiplying, it looks like you should have 110 x's plus 900 over x and x minus 2. That's equal to 10. I just need to pause for a second just to make sure I'm not going too fast. You're good though? Okay.
You sure?
Okay, cool. So we're now at the cross multiply stage. So it's like 10 over 1. So cross multiply. 110x plus 900 is going to equal 10x with x minus 2.
So it'll be 10x squared minus
12. Cool. Okay. That's 900, I think, not 960. 900. 10x squared minus 20x. We have ourselves a quadratic, people.
Yeah.
So I would just suggest quadratic formula. That's probably the best move at this point. So I'm going to bring everything to one side. You've got 10x squared. When you minus this 110x from the minus 20 there, I'm going to get minus 130x. And minus 900.
That's really, really, really dumb.
Okay, I have a suggestion actually. Is everybody okay getting to this spot here where you get your nice quadratic and you can see the quadratic formula sucks. But actually I can see something you can simplify. All of these numbers are divisible by 10. So if you wanted to make it a little bit easier, and this is a rare circumstance, I don't think it'll happen on every example, but you could divide everything by 10. So when you divide 0 by 10, you still have 0. Divide that by 10, divide that by 10, divide that by 10. I still feel like I want to use the quadratic formula, but at least you're not working with 900 and 100.
So you can do that whenever you want, as long as you do it.
So long as you do it consistently, yeah. Does that make sense?
Yeah.
So you could always double everything or triple everything. Just you got to do it to everything. The only reason I suggested in this example is that see how there's a 0 over here? Well, when you double or triple 0, it's still 0. Okay, quadratic formula time. Negative 13. That's positive. Negative 13 squared minus 4, 1 minus 90.
It is 23 underneath there.
Sorry, what? 23? Oh, underneath the square root sign. Like this is 23? Or after you square root it's 23?
After you square root?
Yeah.
Okay. So like that?
Yeah.
Cool. So you're going to need 13 plus 23 over 2. 13 minus 23 over 2. Anybody have answers, by the way?
Ah!
18?
Did you get 18? I got 19 point. Did I type something in wrong? I'm not doing all
You're fine.
17.
That's what I got.
I know, but something's going on with my calculator. That's what I'm saying.
Are you doing like 13 plus 23 divided by 2 typing like that?
No, I'm doing.
Or you're doing with brackets?
What's the square root of 23?
Well, no, I think Shodi said that the number square roots to give 23. So that stuff under the square root sign there, whatever it was, is the number that square roots to give 23.
I'm still getting something.
Okay, I'll talk with you in a second here. Okay, one last thought here. We have 2 answers, but one of them's not plausible. It's this extraneous concept again. Can you have -5 t-shirts in a box? That makes sense?
Someone stole them.
I guess. So you only have one answer, by the way. The answer is 18.
Okay.
So the box has 18 t-shirts. Because you can't have a box with -5 shirts in them.
I got it. I figured it out.
Problem solved?
Yeah.
Awesome. Okay. How do you guys feel?
Good. I actually feel like I understand.
That's our first unit, guys. We're a quarter of the way done the year.
Well,
We're a quarter of the way done, math, senior year.
easier.
Honestly, I actually personally believe this is the hardest unit.
Oh. Then I am in for it.
That's my opinion. It depends on where your strengths are.
When you say it's the hardest.
Okay, so let me tell you about the other units we do, just so you have an idea.
Yeah, I think so.
Okay, the first unit is basically a lot of algebra skills, and I start with that because usually that's not the strength of a lot of students. Algebra is challenging. The next unit is all about probability, and I love this unit because there's so many sports things that you can relate to probability and gambling. And it's a different side of your brain. There's very little calculations involved where you have to do like work on paper. Most of it is just simple adding and subtracting and multiplying and dividing. Like the actual math work is easy. Most of the challenge is just understanding the problem. So everything's a word problem in that unit. The third unit, we look at a whole bunch of different kinds of graphs. So far, you guys probably know about 3 graphs, I'm guessing. You know how to do a graph of like a straight line. Hopefully you've learned about how to do this quadratic parabola graph. And some of you guys in my math class, 20-1, you might have learned about that V-shaped one. Basically, we're just going to learn about more graphs. And almost all of it's done on your graphing calculator, where you guys asked, by the way, so I'm sorry that I'm diverging. You guys remember like these buttons here where there's like value, 0, min, max, intersect?
Yeah.
We do a whole unit where we talk about just different sorts of graphs and how to find their properties, like the high point, the low point on the graph. Okay. We'll talk about exponents, logarithms, sinusoidal. And then the last unit is called logical reasoning, and I kid you not, one of the things that we have to do is solve puzzles.
Oh my goodness.
Yeah. On a diploma once, there was a question where they gave a tic-tac-toe board, and they asked, where should you play next in order to win the game of tic-tac-toe?
Are you kidding me?
No.
Oh,
I am unrealistic.
Yeah.
I'm
So
gonna
it-
sit
Is
there
there a
for- there are
spot
lots
that
of
says
jokes.
jump here and you
Oh,
move?
I hate
Jump
Okay, now that's not the whole thing of the logical unit. The last unit does have a little bit of have you guys ever done Venn diagrams before? You ever heard of those?
Yeah.
Where you do like here is.
It's English.
Anyways, can I just finish and then you guys can go if you want? In the logical reasoning unit, we'll talk about how like this is set A and this is set B, and then this is where you've got A and B combined. And we'll use a whole bunch of notations. Like for example, A, that refers to the section in the middle where you have A and B. Okay. It's notation heavy. It's probably not hard. We'll talk about like A with a line over top of it, or like a slash in front of the A. And what that means is everything that is not A. So for example, if I were to ask you who in this room is 17.
I'm the only 17-year-old. I was like, yo.
Okay, then everybody who is not 17 put up their hand. Now, are we the same ages? For different reasons then, right? So not A just basically refers to everybody else. Does that make sense? So it's not hard. It's mostly notation. If you look at your formula sheet, there's actually a whole bunch of things like this symbol, a 0 symbol. I just have to teach you some notation things, but it's basically, we talk about Venn diagrams. So, my opinion, this unit is the hardest one. Most of the time I find that's what students think. So, but that's because it's so algebra heavy. The rest of them require very little to no algebra. So, okay, I've talked a lot. You guys feel good? So if you want to sign out, if you want to stay, you can. Tomorrow's a work day. Friday's a quiz. Monday's a work day. Tuesday's a unit test. And sometime in there, you got to finish that assignment. Other than that, that's our unit. We're a quarter of the way done. So.
I need to go to the bathroom.
Okay, cool. I'm stopping the video.